So this is the housing we made last time, with the two ceramic bearings inside it, and it's reasonably smooth, but I wasn't really satisfied with the smoothness. I expected it to run on longer than that. It's one of the reasons why I was going to send it to Ollie to get his opinion, but he wrote back and said, don't send it to me, keep it for the meanwhile. So when Dick came, we had a look at this. Having taken it apart, see, there is a bearing here in the top which is just loosely fitting in there and is actually held in by this thing. Well, actually by this one, held in by this thing. But at the other end there's a bearing that is pressed into the dowel ring. And because I couldn't be bothered to calculate it properly, I calculated it on the assumption that the bearing was infinitely stiffer than the dowel ring, which was obviously not a very good idea. And that gave me a press fit of 0.3 millimeters, which is enormous. So I fear that that has not helped this bearing. So if I just engage this and twiddle it, I hope that you can hear this one sounds completely smooth. But if I do the same thing with this one, I think you can feel, I hope you can hear that it sounds scratchy compared with this one. So I think the problem is I need to push this bearing out again if I can without damaging the inner race, and reduce the force on the press fit. So that's what I'm going to do sometime. Ultimately, it's intended that on the bottom of this stainless steel shaft there should be a magnet, and then we should have a Hall effect sensor which will sense the angle of that magnet. So the sensor that I wanted to use is the AK7452, which gives a readout from 0 to 360 degrees in absolute terms and with high accuracy. In fact, it's designed to track, to measure the rotation of a shaft at 25,000 RPM, so it will be more than capable of tracking our wind vane. It's a very, very small device here. It's in a TSSOP 16 package, and the pin spacing is 0.65 millimeters. So to use this, I needed to put it on a breakout board, and the only one I have to hand is this, which is, it is for this pin spacing, but it actually has more pins on it than I need. So I put this on here and very carefully soldered it by hand using a soldering iron, and luckily it seemed to work. But these things are by no means easy to solder because they're so small, and I don't have a microscope. I only have a ×10 magnifier, which was not quite good enough. I bought various magnets for trying out with this sensor, and these seem to be the best ones I've got. These are peculiar in that you'd have thought that a magnet like this was north at one end and south at the other end, but actually it's polarised across this way, so it's north one side and south the other side, on the long side, which is slightly odd, but doesn't seem to make much difference. That explains why they stick together like that. So what I've done is I've taken this green pencil and blue tacked one of those magnets to the end, and I've put a little Delrin collar on it, which unfortunately is not quite straight due to the fact that I drilled this hole freehand. So the actual sensor chip is there, and my idea was that I would put this over here like that, and adjust it. So hopefully I can adjust the height of the thing by adjusting this collar, and then I can rotate it and test what's happening. So I've got it connected to a micromite via an SPI interface, and so I can see what the sensor is returning. Should be 1. If it's 0, it's an error. The status is pretty meaningless, and then it just gives the angle in degrees on the right hand side. So I've also got the sensor hooked up to my oscilloscope so that I can see the SPI interface operating like that. The yellow thing is the chip select, the cyan thing is the clock, the magenta thing is data going to the sensor, and the dark blue thing is data coming back. I had a bit of trouble with this because the sensor is designed to exchange 24 bits of information, whereas both the Micromite and the Arduino CPUs work in 8 bits, 16 bits or 32 bits. So what I'm doing is exchanging 3 8 bits, one after the other, sufficiently quickly so that it appears to the sensor to be a continuous 24-bit stream. And to make sure that that's so, I've actually reduced the SPI clock to 1 kilohertz. Maybe I can speed it up a bit later when we discover what the limitations are there. So what I've been doing is 2 things, just rotating it and sensing it to check that all the angles are reported correctly, but also being able to adjust it up and down in order to try and assess how far away from the sensor the magnet can be and still reliably read. If I move it up a bit, it gives an error. But what I've found is that this Heath-Robinson arrangement here is not sufficiently satisfactory. As you can probably see, the bottom, the position, the bottom of this pen where the magnet is moving around relative to the sensor. It's got to be, in fact, mounted completely firmly, or at least it's got to be in the same axis all the time, and it simply isn't with this very crude arrangement. Of course, when it's in the final sensor, the Delrin sensor housing that Ollie designed, because that's got 2 ceramic ball bearings, it should be perfectly fine. But I'm thinking that to reliably test this, I need something slightly different. What I probably need to do is to mount the sensor in the proper housing. But before I can do that, I've got to replace this breakout board by a bespoke board which is smaller in size, so it will fit inside the housing that we've already made. So that's probably the next thing. So this chip has got to fit inside this housing, and it's also got to be inside some kind of plastic box which stops water getting in, which was one of the reasons why I was trying to assess how far away the magnet could be from the actual sensor, because it looks to me as if this box cannot be more than 1 millimetre thick with the magnet that I'm using. Maybe I need a more powerful magnet if we need to have a thicker box. Well, that's all for now. Obviously, since the last video, this coronavirus thing has ramped up enormously all over the world, and I'm fine, and I hope everybody who's watching is fine. There was a cartoon by Bob in the Telegraph newspaper recently which tickled my fancy. It shows a family in the underground coronavirus survival bunker, which is piled high with loo rolls. And the caption is, did anybody bring any food? I'm probably not allowed to show you this, but there it is. This is a graph I've plotted of UK coronavirus cases against time, And I plotted it on a log scale because this is an exponential growth. So a log scale shows exponential growth as a straight line. The orange line is the number of cases detected, and the red line is the number of deaths in the UK. And you can see that if you project this line straight, it's a very good straight line upwards, it would show that we'd have about 8,000 deaths by the end of this month, had the government not intervened. Likewise, the orange line, which shows the number of cases, would have risen to something like 80,000 cases. So that is why the government has in the last few days announced draconian measures of a sweeping nature, and we must only hope that those measures are in time to make this drop off. I've also been very busy finishing off my new workshop, which is at the back end of my garage. It's 2.5 by 5 metres in size. This room has always been there, but it's been full of junk, so I couldn't use it, and it hasn't been properly decorated. So I've just been doing that, and as you can see, it's nearly finished and is fully capable of holding a couple of lathes and a milling machine. So all I need is somebody to give me a milling machine now, and I shall be laughing. Thanks for watching, and hope to see you next time.